So I'm using Newton's method in this question, and Newton's method helps me find the solution to an equation, or the root for an equation. So what's going on is that if I have the graph of this thing, I don't know what it looks like. Let's just pretend. There's something like this, I don't know. Maybe more like that, because I want to have a root. And I don't know what the solution is. I'm looking for this guy. The root for this. Call it x. How do I know what this guy is? I start with a guess. So my initial guess is x0 equals 7. So I don't know that this is exactly the root for this I just guessed. But what I know though is that if I make my guess is good enough, and if I draw the tangent line for the function of x equals 7, then this, the intersection of the tangent line, the 0 for the tangent line, is a better approximation to x than 7 was. So I'm approximating my function by the tangent line, and instead of getting the 0 of my function, I'm getting the 0 of my tangent line. They're not the same, they're just close to each other, so this just makes my function, or my x1, better or closer to x. Right? X is what I'm really looking for there. So I can, every time, if I wanted to, write the equation of the tangent line, find when that equals 0 and y equals 0, solve for x1. I could do that every time. So that would give me, if I wanted to do that, that would be y minus y0 m times x minus x0. Remember that x0 is 7, y0 is f of 7, right? So f of x0 and the slope of the tangent line is the derivative. And I'm looking for a point that has derivative, or that y equals 0. I'm looking for this point. Okay. So this guy would be my x1. This is what I'm trying to find, but this point does have y equals 0. So 0 minus f of x0 equal to f prime of x0 times x minus x0, distributive property. And remember, I'm trying to solve for this. So I'll add this over on the other side. Or actually, I could have done this differently, right? Would have been a better course of action. Instead of using distributive property to just divide this entire thing. And I would have gotten minus f of x0 over f prime of x0. So I mean, divide this, right? X minus x0, and then x is x0 plus, or minus, if I move this over to the other side, f of x0 over f prime of x0. So this will be the longer way to do this. But you don't have to do that ever if you just remember this formula for Newton's method. So that is your other alternative. So starting with, if you find what f prime of x is, so here on the right side is what you need to do. F prime of x is 5x to the 4th. So what you do to find x1 is you do x0 minus f of x0 over f prime of x0. So that will be 7 minus f of 7, so 7/5 minus 7, divided by f prime of 7, so 5 times 7 to the 4th. So I use my calculator to calculate that. So it's 7 minus, parentheses, 7 to the 5th minus 7 close parentheses, divide by, parentheses 5 times 7 to the 4th. So that will be my, make sure that I haven't made a mistake there on the calculation, but I think it's all good. Even though the parentheses is on the top, I don't think it will make a difference. Right, same result. So that's my x1. I'll just round that to 5.6. If you're entering that into a computer system, make sure that you're rounding to the correct number of decimal places. And then if I wanted to do this again to find an x2, I can just do the exact same thing, but now with x2. So whenever I saw 7 before, I replace my 5.6. So x2 is 5.6 minus 5.6 to the 5th minus 5.6. I forgot that one here. Divided by 5 times 5.6 to the 4th. Do that, plug that into your calculator. So you'll do 5.6 minus parentheses 5.6 to the 5th minus 5.6 close parentheses divided by parentheses 5 times 5.6 to the 4th. And that is 4.48. Again, remember to approximate this to whatever your, if this is using a homework system or some other software to solve this, remember to approximate this. And if you actually solve this using an online calculator, so if I type in solve x to the 5th minus 7 equals 0, the actual solution is the 5th root of 7, of course, right? Because if that equals 0, move the 7 over. X to the 5th equals 7. That's the 5th root of 7. And what's the decimal approximation of this? That is approximately equal to 1.47, which is pretty far away. But you can see that at least we're moving to the right direction. We started with 7, and they're moving to smaller numbers. If I keep doing that, maybe eventually I'll reach that 1.47.